wondered why maths matters outside of school? Spoiler, it kind of shows up everywhere. In this video we're going to break down some key mathematical concepts clearly and simply. Whether you're studying, relearning, or just curious, you're in the right place. Please remember to like and subscribe, I really appreciate the support. Let's get into it.
Let's look at converting my vector a is equal to root 3i minus j into polar form. Now, when it comes to expressing numbers in polar form, you might remember we do this for both complex numbers and also for vectors, so it's a really crucial skill that we need to make sure that we fully have mastered. When it comes to expressing either complex numbers or vectors, my polar form looks something like this, r comma theta, where r is the magnitude of my vector and theta is the angle my vector makes with the plane. Now, in order to find r is simply going to be equal to the square root of my I component squared, which in this case is going to be root 3 all squared, plus my j coefficient, which is -1 all squared. Well, root 3 squared simply just gives 3, and minus 1 squared gives +1, so that gives me the square root of 4, which we can simply just write as being equal to 2. So that's going to be my r component found. Now I just need to find my angle my vector makes with the plane. Now to find my angle, I want to consider tan theta. Now I know tan theta is equal to sine divided by cos. Well, sine is my vertical component. Cos is my horizontal component for both vectors and also just mathematically. So that means that my coefficient of j needs to go on top, that's going to be -1, all divided by my coefficient of my I component, which is going to be root 3. Now, in order to find theta, let's just quickly consider a rough sketch of my Cartesian plane. If I do my all stations to central, I know that tan is negative both in quadrant 2, so somewhere here, and tan is also negative in quadrant 4, so somewhere down here. So I have two possible options where theta could give me -1 over root 3 for tan. Now, there is a few ways to quickly identify if my angle is going to be here in quadrant 2 or here in quadrant 4. If I have a look at my fraction, my top number here is negative. Now, I know tan theta is equal to sine divided by cos, so that means my sine component or my sine part is negative. Also, if I look at the bottom, cosine here is positive. So what quadrant is sine negative and cos positive? That is going to be here in quadrant 4. So all I need to consider is what angle gives me 1 over root 3. That is going to be 30 degrees, and it's going to be 30 degrees in quadrant 4 here. So that means that theta is equal to -30 degrees, or if I put that back into radians, that is going to be -pi/6. So that means that in polar form, a is equal to 2, -pi/6. If I'm given a vector in polar form, such as a is equal to 3, pi/3, and I want to convert that back into Cartesian form, I need to remember that if a is equal to xi plus yj, then x is equal to r cos theta, and y is equal to r sine theta. So that means that a, and I should put my little vector squiggle there, is equal to r cos theta I plus r sine theta j. If I have a is equal to r cos theta I plus r sine theta j, I know r in this case is going to be given as 3. So I'm going to substitute 3 in place of both my r's over here. And my angle is given as pi/3. So I'm going to put pi/3 in place of both of my angles as well. So that means I have 3 cos of pi/3i plus 3 sine of pi/3j. So if I consider my exact values, well, that is 3 cos of pi/3. Cos of pi/3 is a half, so that's going to give me 3 over 2i. Plus, I have sine of pi/3. Well, sine of pi/3 is root 3 over 2 from our exact value triangles. So that's going to give me 3 root 3 over 2j. And I've now converted my vector from polar form into Cartesian form.